Today, we're going to tackle one of the biggest challenges in any democracy. How do you build an election system that's totally secure, but also completely transparent? It's a tough one, and we're going to walk through a really fascinating proposal that tries to do just that. It's called the G2, or Generation 2, Biometric Election System. I mean, that's the fundamental paradox, right? On one hand, you want to be able to check every single vote to make sure the final count is legit. But on the other hand, the secrecy of your ballot, that's like the bedrock of a free and fair election. So how on earth do you solve for both of those things at the same time?
Well, this diagram you're looking at, it's one potential answer. This is the entire workflow for the G2 system, mapping out a voter's journey from the moment they walk in to the moment their vote is counted. We're going to go through this step by step to see exactly how this system tries to crack that code of security versus anonymity.
So let's start at the beginning. The whole process kicks off with a totally new kind of ballot. We're not talking about a stack of pre-printed papers here. This is something else entirely. Okay, so first things first. You walk up to a machine, and it starts with a biometric check. This is all about enforcing a strict one-person, one-ballot rule. Once you're verified, boom, the machine prints out a fresh, unique ballot just for you, right on the spot. It's a security gate right at the very beginning to stop fraud in its tracks. Now, this ballot is really the star of the show. It's not just one piece of paper. You can see it's perforated into 3 distinct parts. You've got the candidate list, that's where you make your choice. Then there's a unique QR code, which acts like a digital fingerprint for your ballot. And finally, a little tear-off slip with a random serial number. That last one, that's your personal receipt, your proof that you voted. All right, so you've got your 3-part ballot at hand. What's next? You head inside this special, self-contained unit to actually cast your vote. And this is where the system is designed to protect your privacy.
And this is what that unit looks like. It's called the G2 Containerized Voting Unit. Think of it like a mini secure room. It's designed with just one way in and one way out, both controlled biometrically. And yeah, the whole thing is monitored by CCTV. But, and this is important, it's not to see how you vote. It's to make sure the process itself is secure and nobody's messing with the machines.
Okay, pay attention, because this next step, they call it the cut, is absolutely critical. This is the moment that makes anonymity possible. After you've marked your choice on the ballot, the paper is physically separated along those perforations. This simple mechanical action is what completely severs the link between any identifier and your actual vote. And this visual just lays it out perfectly. The 2 main parts of your ballot go down completely separate paths. The candidate list, your anonymous choice, gets scanned and dropped into one secure box, all recorded by one camera. The QR code, its digital twin, gets scanned and dropped into a totally separate box recorded by another camera. And that serial number slip, that's yours. You pocket it and take it home. But wait, there's more. Just separating the ballot is only the first layer of making it anonymous. Once those votes are deposited, a pretty cool mechanical process kicks in to randomize them even further, before anyone even thinks about counting them. And this is where things get really clever, almost kind of low-tech in a brilliant way. The physical ballots, the candidate lists, literally fall into a gravity-based shuffling system. It barely has any moving parts. It just uses gravity to tumble and mix the ballots from a bunch of different voters all together. It makes it totally impossible to know what order the votes were cast in. The official term for this is paper batch consolidation. But really, all it means is that by shuffling and grouping these paper ballots together before they're even touched for counting, you completely erase any connection between the time a voter walked in and where their ballot ends up in the stack. It's another layer of privacy. Okay, so let's recap. We've got biometric security, we've got anonymity in the voting booth, and we've got a mechanical shuffle for good measure. Now, how do we actually get the results out to the public in a way that's transparent, but still protects every voter's privacy? Well, here's how. The system doesn't just spit out results one by one as they come in. No way. Instead, it aggregates all the vote counts into batches, and it only releases the totals on a public display grid every hour. So you get these near real-time updates, but you never see individual votes popping up. And this right here shows you exactly why that's so important. If you were posting results individually, in real time, someone could, try to link a person entering the booth to the vote that appears on the screen just a few moments later. By grouping the results into hourly batches, that direct, traceable link is completely and totally broken.
All right, now we're getting to the real heart of this system's claim to transparency, the audit trail. This is how the system is supposed to prove its integrity. It's all about creating multiple, independent records for every single vote.
I want you to remember one number: 4. 4! For every single vote that's cast, the G2 system creates 4 separate video records. And the crucial part is, these records are stored by different, independent agencies. No single person or group holds all the keys to the kingdom.
And the real genius here isn't just that there are 4 recordings, it's how the data is siloed. I mean, look at this breakdown. You've got 4 different agencies, and each one holds just one piece of the puzzle. The election verification office has the video of you entering and leaving. The polling office has the footage of your anonymous vote being deposited. The recount office has the QR code scan. And the complaints office has the record of your serial number being created. And get this, they are not allowed to share data with each other unless a formal complaint is filed.
So, you've got all these separate pieces of a puzzle, held by different agencies. Who holds the master key to connect them all? You, the voter. That little serial number slip you tucked in your pocket and took home, that is the only thing that can link all 4 of those recorded events from your specific voting session together. And they've designed the verification process to be super simple, at least in theory. You'd use your serial number in a special app and it would pull up the time-stamped events of your session. You could see exactly when you entered, when your QR code was scanned, and when your vote was deposited. If anything looks off, if something doesn't match, you can immediately file a complaint to get investigated.
This quote just sums it all up perfectly, doesn't it? By decentralizing the audit trail by spreading it out, the system makes sure that no single point of failure or corruption can compromise the whole election. The only way to bring all that data together is if a voter, the person who holds the key, picks off a formal review.
And that really brings us to the big final question. This system proposes a world where every single voter has the power to personally audit their own participation, all without ever giving up their anonymity. So I'll leave you with this thought. If every single one of us could independently verify that our vote was cast and counted correctly, what would that ultimately do for our trust in the entire democratic process?